Hello friends, this is Piyush Raj and this is my friend Umakant. We are here just to tell you about the big data technology.
Thanks, Pius. Welcome. So, friends, welcome to eSolution Park. So, we'll start with Bigdata Hadoop technologies and we'll explain you, we'll do the go through of all the related Hadoop technologies like Hadoop ecosystems technology and all. We'll slowly start with the today's topic, that will be big data. We'll define why big data is required, then we'll come to why Hadoop is required, then we'll go to HDFS architecture and define how the architecture works for the Hadoop ecosystem. And we'll in the coming session we'll cover the architecture of Hadoop 2.x onwards and how it works with Yarn. That will be the next day's topic. Okay, so now friends, what is big data and why big data coming into picture now? The big data is the large volume of data which actually was unearthed due to traditional databases, due to the other approaches we were following previously. We were not able to analyze the data properly.
So Uma, I have a question here. So the data is really big, so it is named as big data. What?
Yeah, so previously we used to have the data big, but it was only the structured data we used to report. Now you can, with the growing data volume, you can report unstructured as well as structured data with the help of Hadoop ecosystems. So next is why big data came into picture is because of the cost we are paying, because of the type of data we are getting, because of the approaches we were following previously was not good to report the huge volume of the data. So that's what the big data will help us to get that unearthed data, to do the analysis, to report the data properly, so that we'll get a business insight proper from those unhidden data which were previously useless for traditional databases.
Okay, Uma, I do have a question here. So did you just said a structured data and unstructured data? What is this, man?
Yeah, so structured data is like the data you are getting from somewhere which is in a properly arranged manner, which have a proper defined meanings of a data set. But unstructured data which you are getting just like getting data from sensors or getting data which is from servers which you don't know really in which format you will get, that is called an unstructured data. So data which currently we store in a traditional databases is more or less structured data, where you define a proper table, have a columns, and then you store the data. Okay, next we'll move to Hadoop. Why Hadoop? Now what we defined previously was the volume of data was used. We need to have a framework which used to support this quantity of data. Even we have different quality of data, structured and unstructured. With the proper designing and distribution of data, it needs to be supported with framework. Okay, so Hadoop is coming in picture. It's an open source framework which support the data, means whatever the data you are getting from any source, that framework will help you to store in a proper manner, distribute those data in properly in different nodes or different databases or different hard disks, and help you to get the proper insight in a very efficient and faster way. So that's what the Hadoop is coming in the picture. Means I have used volume of data. With the help of Hadoop, I can efficiently store the data, I can efficiently distribute it, and I can efficiently, in a very less time, I can pull it and report the data. Okay, that's why the Hadoop is coming in the picture.
Okay, I got your point, Uma, but the thing is, why can't we use the traditional database here? Can't we have the same thing there?
Yeah, we can use the traditional databases. The problem with the traditional databases, the cost it going to. It's
Yeah.
costing us very much because of the whatever the hardware we were using for this for traditional databases. Secondly, the volume of data is growing so much that you cannot distribute, means the proper distribution was not happening with the traditional databases. So what happens with the Hadoop is you distribute your tasks. So once we'll come to architecture, you will come to understand why this, how the distribution is happening and how this supports, the Hadoop supports and how it differs with the traditional databases. Okay. So next is what is HDFS. So for now you have huge volume of data. You have Hadoop as a framework. You must have something which need to store your data. So that requires a file system. That is the file system known as HDFS file system. It's a fault tolerant file system, which is properly we call it Hadoop distributed file system, which actually stores your huge volume of data in a proper distributed way. That's what the HDFS is known as. Okay.
So all the data is stored in a file system.
Yeah, all the data will be stored in a files. In whatever the data you are getting from different sources or different either it is structured or unstructured, it will be kept in a HDFS files.
Okay.
Okay. So next is HDFS follows the master slaves architecture. Master slaves architectures. What I means is it will have one master node that will taking care of rest of the slaves nodes. So the Hadoop coming in picture because it creates a distributed environment. What that distributed means, you have one task. If you distribute in several persons, each one is capable of doing that task. That task will be done in a very less time. Okay, so this way HDFS works, and due to this it computes a large volume of data in a very efficient and fast. This is the main advantage over the traditional databases. Okay.
Yeah, so now I will explain the HDFS architecture of Hadoop. So let's say we have one client which wants to store a data in data nodes. So what does client do? Client will ask to the name node. So what does name node do? Name node will have a namespace. Namespace will contains the metadata information of all the data stored on a data nodes. So namespace, each name nodes will have only one namespace. We have one secondary name node also, which actually contains known as a backup of name node, but actually this is not a backup of name node. Just it keep taking the name node snapshots on a regular interval. This is just we misconcept that the secondary name node is a backup of name node. So secondary name node is just whenever the fail happens, we just copy logs from secondary name node to name node, and we lose some data while doing the failover. So this is one of the major fallback we had with Hadoop 1.x, which we will cover in a later section, how we improved with 2.x version of Hadoop. Now how we were trying to store a file on a data nodes. So what happened, we got metadata information from name node, means name node told client that you go and store a data on data nodes 2. So what will happen now, whatever the client was trying to store a file, it will go to the data nodes 2 and store that file, and then data node will send acknowledgement to clients. So just whatever the storing and processing is happening here is just don't think that it's every time it's going through name node. It's directly client is connecting to data nodes and performing the tasks. Okay, so now what will happen, client and on a regular interval these data nodes will keep sending the heartbeats and block reports to the name node. So the two important concepts of data nodes is it's sending heartbeat.
So my heartbeat means it is alive, right?
Yeah, heartbeat means we are feeling that data nodes is live. So name node will aware that whatever the data nodes is present in a clusters is live.
Or what if a data node won't send this heartbeat?
So name node will mark that data node as a dead. That data node will consider as a dead, and the connectivity to this will be closed. So no operation will be done to this data nodes.
So what about the data in data node 2 then? What will happen to that data?
So whatever the data we had, we have a two replica of that data. So that will contains on a different data nodes.
So you are trying to say we have a replication factor of 3.
Yeah, we have replication factor in a Hadoop, which is actually by default is 3. We can modify this value to
Customizable,
customizable.
Right? Okay.
Okay, and another thing is whenever the replication factors, first is known as availability factor and second is known as security factor. So what does it means that whenever the name nodes, whenever you trying to store a file, that first file will be stored on a first data nodes in a rack, then the second copy will copied in a different rack, means it will not copy in a same rack.
So name node will have the
Name node will
awareness of racks also, right?
Yeah, name node will have all the metadata information as well as it aware that which copy is stored at which data nodes.
You mean to say rack, right?
Yeah.
Okay.
Okay. So this is how the internal architecture of any file read and write operation works in a Hadoop clusters. Okay. So in the next session we will explain how this name node is associated with job tracker in Hadoop 1.x and data node is associated with task tracker. So this is 1.x overall architecture. So for next section, we will cover the deep dive of each of the components of Hadoop 1.x architecture, like name nodes, what all the file it involves, data nodes, what all it contains, what all daemon processes it runs, all those things we'll cover in a next section, and then we'll move to yarn and further in a architecture section. Then we'll cover 1.x versus 2.x and the differences of this Hadoop version. So we'll cover 1.x versus 2.x. What is the architecture difference? What is the benefit we'll get over 2.x when we move from 1.x onwards? And then we'll cover the detailed whatever the MapReduce framework is removed or whatever the yarn framework is coming in picture. Those things we'll cover in the next upcoming sections. So for this, subscribe us for more technical and informative video, or ask us anything about big data and technology anytime. Do put your comments for any queries.
Okay guys, thanks for watching the video.